This is part 2 of the density notes. We're going to do example 3 and 4. Example 1 and 2 and all the vocabulary were in the first part. And then we're also going to explain our choice practice for the week. So example 3 has identifying an unknown. This is another application of density. Because it is what we call an intensive property, it is part of the identity of a sample, or sometimes I refer to it as the personality of the sample. For example, we know that water's personality, if you will, is clear. It doesn't have a smell. It is not toxic. These are properties that are intensive, part of water's character. But it's different from isopropyl alcohol, which is rubbing alcohol. Although they're both clear, rubbing alcohol has a really distinct smell, and that is part of its characteristics, its personality. So the same is true of density. Water's density forevermore is always 1 gram per milliliter, no matter how much of the sample you have, just like it will always be clear, non-toxic, and no odor. And that is true for any pure substance. So we have a table here with 5 different materials and their densities, which again do not change no matter what, as long as it is pure tin, aluminum, titanium, platinum, and nickel, the ones listed in this table. They will always have the listed density shown here, no matter what. So you can use that information. If you have mass and you have volume, then you can calculate the density and figure out what type of material it is. Okay, so we're going to take a second to do this math problem that will help us identify what unknown we have. So it says, is foil made of tin or aluminum? A sample of foil has a mass of 4.11 grams and a volume of 1.52 milliliters. What is the material? We can calculate the density from this problem. Oops, that's a 4.11. Got cut off there. By dividing the two, because they're a ratio. Remember, D equals heart, or M over V. Divide the two numbers and you'll have the density. 4.11 divided by 1.52. Put it in your calculator. And you get 2.7 grams per milliliter. Don't forget your units. Mass is grams, volume is milliliters, so these two units become the final unit, grams over milliliters. Take a look at your table. What material is the foil made out of? Aluminum, because it is 2.7. It doesn't matter how much of the aluminum we had, as long as the ratio between its mass and volume match our density, then that is its identity. Aluminum. Our foil is aluminum. Now, if someone claims to have a platinum sample, its mass is 7.2 grams. What must its volume be if it's truly platinum? You can also use, we also caught off a number here, 47.2. We can also use the density formula to determine things like volume and mass, the same problem, but now instead of solving for density, we're going to solve for volume. So this time we're going to use the density in the table for platinum, same equation. So I'm going to write it down, D equals M over V, but we're going to plug in different values this time. D, we know, is 21.45 because of our table. And the mass in the problem is 47.2. That means we're solving for the volume. Now we're going to just solve for our variable, but we have to get it out of the bottom. So this is where some algebra skills will come in handy. Multiply both sides by V so that we can get it out of the denominator here. And then we're going to have 21, let's rewrite it here. 0.45 V is 47.2. Solving for V will divide by 21.45. Again, this is just some algebra skills. Solving for a variable. Canceling out those numbers. Now we can plug this into our calculator. 47.2 divided by 21.45, and we get 2.2 as our answer. Units on this, look back to what your volume units were. They are milliliters. Remember, the only options for volume are milliliters or centimeters cubed. In all of these listed on our table, volume is measured in milliliters. Lastly, you find a metal sample with a volume of 3.14 milliliters. What will its mass be if it is titanium? What if it is nickel? Okay, we have two problems now where we're going to find the mass. Okay, same process, similar, I should say, as the one we just did, but now we're going to solve for mass instead of volume. So first, let's focus on titanium, which has a density of 4.54 grams per milliliter. We don't know the mass. I'm going to leave that as a variable, but we know its volume is 3.14 milliliters. To solve for M this time, we're going to multiply by 3.14. And that will give us our mass. Pop it into your calculator. 4.54 times 3.14, and we get 14.26 grams. There's our mass. 14.26 mass. That's if it's titanium. Well, what if it's nickel? If it's nickel, our density will be different. 8.9 density. Same thing, we don't know the mass, but we do know the volume. Multiply. And solve. Multiply here. 3.14 times 8.9. If the sample is nickel, then the mass is 27.95 grams. So if it's titanium, there's our mass. If it's nickel, there's our mass. Based on the ratio of mass and volume, which give us density. So there's another application of density. We can use it to identify an unknown or find the mass and volume of a sample that we do know. It's density if we have the other option, whether it's volume or mass, because that ratio will always be constant. Our last application of density is to analyze a slope of a graph to find density. Again, using some algebra skills, remember that slope is defined as rise over run. And on a graph, rise are all of your y values and run is all of your x values. In this graph, our y values are mass. And our x values are volume. That should look familiar. M over V, that is density. So, by this work here, we can see that the slope of a mass versus volume graph is the density. So let's apply that to find the density of our samples from its graph. Use the graph to find the density of substance A. Use the graph to find the density of substance B. All right, so when you're finding slope, remember you're actually taking the change in y over the change in x. That little triangle I just drew is actually a delta, which means final minus initial. It's just the change, the difference between the two, so we can track the actual slope, not just 2 points. So let's find 2 points on substance A. They both go through 0, 0 at the origin. Let's make it easy and make that our first point And there's another clear point at mass 80 and volume 50. Since we're using the origin, it would be 80 minus 0 as our y change and 50 minus 0 as our x change. So we have 80 over 50, or I'm going to put that down as 8 over 5. If you put that in your calculator, it will be 1.6 grams per milliliter. There's our density with a unit grams per milliliter. Same thing for substance B. Let's find a clear-cut point. There's one at mass 20 and volume 40. So again, change in y is 20, change over x is 40. I'm going to simplify that to 2 over 4, which is 1/2 grams per milliliter. Water has a density of 1 gram per milliliter. Graph the line representing water. If its density is 1, that means its rise over run needs to be 1 change in mass to 1 change in volume. So I'm going to plot 10 and 10, 20 and 20, 30 and 30, 40 and 40, and so on, giving us a slope of 1, where the change in mass is the same as the change in volume. So this would be the slope of water on a mass versus volume graph. Using what we talked about in the previous video, where things with larger density will sink, things with lower density will float, circle how substance A and B will behave in water. Remembering water has a density of 1 gram per milliliter. Well, substance A has a density of 1.6. That is greater than water, so it will sink. And substance B has a density of 0.5, which is less than water, so it will float. There's our final application of density. So we've got 4 ways to apply it. We can see it visually of the compactness of the particles. We can interpret when things will sink or float. We can identify an unknown, and we can analyze slope from a graph to find density. Now on the next few pages, you're going to choose 2 problems from each practice set to complete. Each practice set is 1 page front and back. So there are 4, and each one has some problems. So visualizing mass and volume and density has 4. You just need to choose 2 from all of those. Observing behavior in water has 5, just choose 2. Identifying unknown objects has 2, so do both of them. And analyzing slope for density has 3 problems, choose 2 of them. So these, in our first practice set, they're not actually numbered, but this is number 1, number 2, number 3, and number 4. Wherever they're bolded, that's a problem, okay? So choose 2 of those. Sink or float are all numbered, choose 2 of those. Identifying unknown objects, you're going to do this whole page, 2 of those, front and back, and then analyzing slope for density, choose 2 of the 3 here. So you could either do the front 2 or the back problem with 1 in the front, okay? And then that leads us into tomorrow's work, okay? So there's our practice choice. Don't do all of it. I mean, you can if you're feeling super into density, but don't think that you have to do all of it. I know it's a lot of work. I just want you to choose 2 problems from each practice set so that you are doing a little bit of practice of each. And if you want to try your hand at some more practice problems, go for it. You can do them all if you'd like. But I will send out the key, at the end of the week for you to see all of the problems, even the ones that you did not end up completing. So that is the end of our part 2 notes. I'll see you at co-op.